This is an online periodic table. It's called ptable.com. I really like this periodic table. You can change features on it. You can look up different information. If you click on any of these, it will give you information on the periodic table elements. But if you take a look here, our stair-step line went kind of like this. And if we hover our mouse over the non-metals, you'll see that they are mostly on the right side of the table, except for hydrogen, which is number 1. And hydrogen is a gas and it is a non-metal. So those are our non-metal elements. Now, if I move over to metalloids, you'll see that these elements are on the stair-step line. They include elements like silicon, which is very important for solar cells as well as computer chips, germanium. These elements have properties that are a little bit like metals and a little bit like nonmetals. They're considered semi-metals. And their electrical and material properties are ideal for things like semiconductors. Finally, we have metals, and you can see that most of the table is metals. Metals are very important in our world, and we have many, many metals, and you can see that most of the metals are solid except for mercury, which is liquid metal, very unusual metal, very toxic metal, but a metal just the same because it has the same electrical properties and thermal properties as a metal would. So again, here we have our metals, we have our metalloids, and our nonmetals. So we can classify our elements into those 3 types. And those 3 types have distinct electrical, material, thermal properties, different chemical and physical properties, which affect the behavior and structure of the compounds and materials that they make up. Yeah, it's fascinating. It's amazing how all these different elements can work together to create our surroundings and our world. So I'm gonna go back to my other periodic table now, the one that hopefully is one of these days you'll have in your hand. So going back here, let me get rid of all this stuff. The last thing I want to talk about is the fact that some of these elements are not single atom elements. So an atom, as you have heard from science class, is the smallest piece of matter that can exist. Now, that's not strictly true. We do have nuclear reactions that can break atoms apart, but for our chemical purposes, for chemical reactions, we're going to consider the atom the smallest piece of indivisible matter. We can't divide it further. Now, most of the elements on the periodic table, for example, if we look at, let's say magnesium. If we looked at magnesium with a very powerful microscope, very powerful. In fact, we have to use something called a scanning electron microscope. We would see that magnesium is composed of individual magnesium atoms. That's a magnesium atom, that's a magnesium atom, that's an atom, that's an atom, that's an atom. Okay, you get the point. Okay, that's what magnesium looks like. And it would be arranged in some periodic pattern. However, there's, of course, in life and science, there's always, things do weird things. Not really weird, but that's just the way they are in nature. On the periodic table, 7 of the elements are not composed of single atoms, but instead are diatomic. And there are 7 of them. I'm going to circle the 7 diatomic elements. So we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So you can see this kind of looks like a 7. That might help you remember that there are 7 diatomic elements. So what does that mean, diatomic? Di means 2, 2 atom elements. So if we looked at nitrogen, we would not see single atoms. Nitrogen in the air is about 78% of our atmosphere. Nitrogen, if we looked at it with a very powerful microscope, would look like this. It would be composed of 2 atoms bonded together into a nitrogen molecule. Still a pure element, still a single element, except that now, instead of having single atoms, as in the case of magnesium, we have a gas which is composed of molecules, nitrogen molecules. And so nitrogen is not N. Magnesium over here is Mg if we wrote down its element. If we said, oh, well, we have some magnesium, we could say, oh, we have Mg. But if we say we have nitrogen gas, we can't say we have N. Instead, we'll say we have N2. That 2 to the right of nitrogen symbol means that there are 2 nitrogen atoms bonded together and they make a molecule. So besides nitrogen, we have O2, F2, Cl2, Br2, I2, and let's not forget H2, hydrogen. So these are our 7 diatomic elements, these 7 right here, and they are nitrogen gas, oxygen gas, fluorine gas, chlorine gas, bromine liquid, iodine solid, and hydrogen gas. So I hope you found this video helpful in thinking about the periodic table, and we will be using these features all year. So if you need to review any of these things, watch the video again. I know that it seems like a lot of information, but as you look at the periodic table more and get familiar with it, and you start memorizing some of their symbols and names, you'll find that it really has a wonderful pattern, and it shows a lot of features that will affect the structure and properties of the things that they make up, compounds, mixtures, etc. All right, enjoy.